us. Today we explore drainage basins in South Africa, their patterns, and how water moves across the land. A drainage basin is an area of land where all precipitation flows toward a common river. South Africa has many basins, each shaped by topography, climate, and rock structure. Major river systems include the Limpopo, Orange, Vaal, Tugela, and Great Fish rivers. The Orange River flows west to the Atlantic, while the Limpopo flows north. These rivers shape the land, provide water for agriculture, cities, and industry, and support ecosystems along their courses. Understanding drainage basins helps us study river systems, water resources, flood management, and the interaction of surface water with infiltration, groundwater, and the water table. Let's start with key concepts. We'll cover drainage basins, catchment areas, tributaries, and more. A drainage basin collects all rainfall that flows to a river. A catchment area is the land feeding water into the river. Tributaries join the main river at confluences. Watersheds separate basins. Interfluents are higher land between rivers, and rivers flow from source to mouth. Understanding these terms is essential for mapping and managing water flow. Next, we look at how water moves. Surface runoff, infiltration, groundwater, and water tables are important. Surface runoff is water flowing over land toward rivers. Some water infiltrates the soil, replenishing groundwater, which rests above the water table. Soil properties, slope, vegetation, and rainfall influence infiltration and runoff. These processes determine river discharge, flooding potential, and the sustainability of water resources. Vary by flow. Permanent, periodic, episodic, and exotic rivers have different characteristics. Permanent rivers flow year-round, while periodic rivers flow only in wet seasons. Episodic rivers flow irregularly after heavy rains. Exotic rivers originate outside arid regions and flow into drier areas. Identifying river types helps explain water availability, agriculture, and settlement patterns in South Africa. Drainage patterns reveal the underlying rock structure. Let's explore their patterns. Dendritic patterns form on uniform rock, resembling tree branches. Trellis develops on folded rock with alternating resistance. Rectangular follows fractures or faults. Radial drains from volcanic cones. Centripetal drains into basins. Deranged appears in glaciated areas, and parallel develops on steep slopes. Patterns indicate topography, geology, and erosion processes. Drainage density varies across landscapes: rainfall, evaporation, soil, vegetation, and more. High drainage density occurs in areas of high rainfall, steep slopes, impermeable soil, or sparse vegetation. Low density develops in arid regions, flat areas, or permeable soils. Drainage density affects flooding, river velocity, and erosion. Infiltration rates determine how much water reaches rivers versus groundwater storage. Finally, we look at stream order and discharge. A stream order classifies rivers from first order, smallest, to higher orders as tributaries join. River discharge is the volume of water flowing past a point per second. Laminar flow is smooth and orderly, while turbulent flow is chaotic and fast. Stream order and discharge help manage water resources, predict flooding, and study river dynamics. Let's recap. Drainage basins, river types, patterns, density, etc. Drainage basins collect all water from rainfall, with surface runoff, infiltration, and groundwater influencing flow. Rivers vary in type and pattern depending on geology and climate. Drainage density, stream order, and discharge determine river behavior. Understanding these concepts is key to water management, flood control, and sustainable development. Okay, grade 12, thanks for joining us today. I'm Madam Shabangu. Until next time, happy learning.